What is good in your life, Grizzlies? It's the end of the week, Thursday. Hope you're having a good one. We've got a pretty easy day today, but I want to make an announcement that next week on Thursday will be our very first quiz of the year. The quiz will be on these two forms right here. Are you able to find the vertex when you're in standard form? Could you take an equation in standard form and then rewrite it to look like this form? When you have an equation in this form, would you be able to draw a graph of it? And would you be able to describe all the transformations? So the last 4 lessons or so, that's what the quiz is gonna be on, these two forms. Today, we're introducing one more form. Let's get started. Let's say this picture is modeling a ball getting thrown in the air. Intercepts can be very valuable points. The most important point is the vertex, right? The top or the bottom of a quadratic. But intercepts can be valuable too because it can tell you how long the ball was in the air or maybe how far the ball or whatever object traveled. So the intercepts can be important points too. So here's the general equation for intercept form. It starts with y equals a. There's always an a value in the front. Even with standard form and vertex form, intercept form starts with an a value. After that, we have 2 factors. These 2 factors let us know where the intercepts are, just like that. Okay, so whatever's in these parentheses here, that's going to tell me the location of the intercepts very, very quickly. Let me show you an example. Our first example, find the x-intercepts and the vertex for this equation written in intercept form. So we're going to find the x-intercepts fairly quickly, but we also want to locate the vertex because that's the most important point on a parabola. Right here I have 2 different factors, x minus 1 and x plus 5. If I set each one of them equal to 0, I can find the intercepts just like that. So in this first factor, I have x minus 1 equals 0. To solve this, you would add 1 to both sides, so x equals positive 1, which means it crosses or touches the x-axis at positive 1. Let's do the same thing for this second factor. We have x plus 5 equals 0. If I subtract 5 to both sides and solve for x, I would get x equals negative 5. That means it crosses the x-axis at positive 1 and also at negative 5. Notice a pattern between the numbers in the parentheses and the x-intercepts. It's very quick and easy to find the x-intercepts. That's why they call it intercept form. Finding the vertex is a little bit harder. Let's check it out. All right, so I know where the x-intercepts are. To find the vertex, okay, wherever the x-intercepts are, I know the vertex is either at the bottom or the top of the hill. But what I also know is, does anyone remember what that line's called? It's called the axis of symmetry, right? So the x-intercepts, this axis of symmetry would be directly in the middle. It'd be cutting it in half, right? And I know this picture doesn't look perfect, but the intercepts would be the same distance away. So I know the vertex is in the middle of these 2 points. So how do I find the middle of these 2 points? We're going to add them together and divide by 2. Here's the equation. You take P and you add whatever Q is and you divide it by 2. So we know where P and Q are. We know where the x-intercepts are. So let's add those together and divide by 2. We've got 1 plus negative 5, all divided by 2. I can use a calculator or just my head and know that that is negative 2. That gives me the x-coordinate of the vertex. That tells me where the middle is. So once I know the x-coordinate, how do I find the y-coordinate? Yeah, just like before when we were in standard form. We're going to take negative 2 and we're going to plug it into our equation. So let's see what happens here to find the y-coordinate. It's going to say negative. We've got negative 2 minus 1. And then we have negative 2 plus 5. I'm taking this 2 and I'm substituting it in for x. Pretty easy problem to solve here. We're going to have, this is negative 3, and we need to multiply it by a positive 3. So now I have y equals negative 9 times a negative. It gives me positive 9. So my vertex is located at negative 2, 9, and I have 2 x-intercepts right here. Let's draw a picture of it. Okay, I'm gonna draw a picture of this, a sketch, but the assignment said find the x-intercepts and the vertex. I've done that. Here are my x-intercepts. Here's the vertex. I'm actually finished, but just to give you an idea of how you could use this to draw the picture. If the vertex is at -2, +9, I'd go left 2 and maybe up 9. I'm making a sketch, so I'm just gonna label it. I also know that it's touching or crossing the x-axis at +1, so I can call that +1, and at -5. So over here, I call that -5. So here are 3 points that I could draw of this parabola. Totally makes sense that it's reflected upside down. The A value is negative. It's getting reflected. It's a sad parabola. So even from the vertex, I could go down 1 and put a dot to the right and a dot to the left. And this is a sketch of what the graph could look like. You don't need to do this for your homework. You only need to find the intercepts and the vertex. Let's take a look at one more example, and then we'll have you try some for homework. Okay, here's our second example. I'm gonna go through this one a little bit quicker. We wanna find the x-intercepts and the vertex. Let's start with the intercepts. Cool. I see 2 factors here. I see x -4 and x + 6. So the first factor, x -4, I know to solve that for 0, I just add 4 to both sides, so x equals +4. Right here we have x + 6. I already know that the intercept is going to be -6. You might remember solving for factors when we were x factoring earlier in the year. Pretty simple to find the intercepts. That's why they call it intercept form. You find the intercepts like that. But now I want to know where the middle of these 2 points are and able to locate where the vertex is. So let's find the middle of these 2 points. We're going to add them together. I got 4 plus -6 and then divide by 2. This gives me -2 divided by 2, which is -1. That represents the x coordinate of my vertex. Got to find the y coordinate as well. So let's take this -1. Let's plug it back into the equation for x. That'll let us know what y equals. We've got -1 - 4 and -1 + 6. I'm going to do the parentheses first. This gives me -2 times -5 and +5. So I have -2 times -25, and that gives me +50. Pretty big number there. My vertex is located at -150. Maybe I'll label it. And the 2 x-intercepts are at +4 and -6. Don't need to draw a sketch or a picture just yet. We're locating the intercepts and the vertex. Hopefully that feels pretty simple to end the week. Again, a reminder, next Thursday, there will be our very first quiz. It will not include this stuff. It'll only be on standard form and vertex form. And you could use all your notes and homework if you need to. Let's check out the assignment for today. So here's our last assignment for the week. We're gonna do problems 7 through 10. It says graph the quadratic function. You don't need to graph it. Simply find the vertex and the x-intercepts for those 4 problems. And then for 31 through 36, we're looking at these equations and we're trying to match it up with the correct graph. That's not too hard. So, guys, have a great weekend. Be smart. If you can't be smart, be safe, and we'll see you next time.